Alright, so we're going to find the sum of that expression, 6I times I minus 1 all over n cubed, as I goes from 1 to, let's just say we're doing 10 here first. Now, just doing 10, do you feel like you could probably do that just by hand? Mm-hmm. Plug in a 1. N, remember, is 10. You know, if this was 10 per moment. Obviously, that would change this to 10 cubed down here. But could you add those 10 numbers together?
Yeah.
Sure. Feasible, not great, but probably not something you really want to do. Okay? Now, if I change that to 100, the answer is definitely no, I'm not adding 100 numbers together. Okay? So, you're not going to want to do them individually. We're going to want to use some of our properties and some of our formulas to help us get an expression in terms of n. Then all we need to do is plug those numbers into that final expression and we can get our answer pretty quickly. Okay? Alright. N is some number, correct? Okay? So this n cubed then is actually some fixed number. Right? It's not gonna, you're not plugging in different numbers for n within the same problem. Like if we're doing it for, you know, n is 1,000, you know, if we're adding together the first 1,000 terms and n is stuck at 1,000, it's not changing. But, you know, what you're plugging in for I changes. You plug in a 1, plug in a 2, plug in a 3, and so on. Okay? But what I'm trying to get at is I could envision this as 1 over n cubed times 6I times I minus 1. And then where can I move that 1 over n cubed? Out to the front, because it's kind of like that, that k value, right, that I showed you in the property. It's like a coefficient, it's a fixed number. K is going to be some value, or 1 over n cubed is going to be some value. So I can bring that out to the front. Okay with that step? Okay. So now, that's great. I know that, you know, whatever n is, if n is 10 or 100 or 1,000, that's simple. I can just plug in a 10 or 100 or 1,000 right here, but I still need to do this part back here. Now the problem is this is still a product, and I didn't give you any cheats for, you know, or shortcuts for a product, right? Okay. But I did give you some properties for when there was, you know, some sum and additions, right? I said you could split it up then and do individual sums. Could we somehow make this from, instead of being a product, into just the sum or difference of two terms? What could we do? Can you distribute that? Yeah, that's what I would do. So 1 over n cubed times the sum as I goes from 1 to n of, it would be 6I squared minus 6I. So now, since we have a sum or difference, what can I do? Separate it into two separate sums, right? Okay.
Man.
So 1 over n cubed. So what I'm going to do now, you can write 1 over n cubed with each of them, but I'm just going to do kind of a big bracket, okay? And then separate them inside this bracket. So that would be I goes from 1 to n of 6I squared minus the sum as I goes from 1 to n of 6I. That's how I would do it. If you don't like the bracket, just make sure you put the 1 over n cubed in front of each summation. You guys with me on that? Algebraically, that makes sense? Because we're taking 1 over n cubed times whatever we get for that answer. So we got to make sure 1 over n cubed is being multiplied by both of those individual sums. Organization and neatness of work is really important in this stuff. But you guys all are really good at that. So, okay, now let's look at those individual sums. Okay, what do you think I'm probably going to do with this one? Think of the formulas I gave you. We don't quite have one of those formulas, but if I use one of the properties, then I should be able to use one of those shortcut formulas.
So if you do bring the 6 out?
If I bring the 6 out, then aren't I adding together the perfect squares, the I squareds, and don't you have a shortcut for I squared? Okay, and then the same thing on this one. If I bring the 6 out, I got a shortcut for the I, right? Exactly what I would do next. It's kind of fun.
It's such a nerd thing to say.
Yeah, well, I'm a math teacher, so.
Are these those long problems?
They look
I used
long.
to hate these.
Used to, did they get better?
No?
Great.
The sense of fulfillment when you solve one of these is just awesome. It's like, you don't get that feeling
I
ever?
remember I got one way off last year because I forgot like one of my negatives or something like that at the very beginning, so my answer was way off. That was my only problem.
Yikes.
Yeah.
So dumb.
What do you get on there?
Well,
Swimming.
So far so good?
I guess.
You
should Okay.
told us what we all was before we started
Very sorry.
But look at all this space. Oh, I'm not mixing it up.
Well, when you read in line.
Okay. Now, we can replace this part, the sum of the first n perfect squares, with the shortcut, right? To get it in terms of n.
Oh.
Okay? So I'll have 6 times, that shortcut is n times n plus 1, I don't have this one quite memorized yet, times 2n plus 1, all over 6? Okay, right there.
So are you gonna give us all these formulas? Oh, God.
Great.
Minus 6 times, what's the shortcut for adding the first n integers together?
Hold up. Is that 6? That first 6 times the whole fraction?
It's 6
Not
times
in that one.
that fraction, yep, because, different colors here. Isn't this, Becca, isn't that equal to
Oh, yeah.
this right here?
Okay.
Those are that's the shortcut, right? Okay. Minus 6 times what?
Times n plus 1 divided by 2.
Yep. Okay. I mean, I suppose you could, if n is actual a number, I suppose you could call it quits and just plug that number in right now if you wanted to. It's a lot of different places to plug n into. I'm going to try simplifying this a little bit.
I simplify them so.
Oh my gosh. The 6's cancel. Right? Okay. And then I'm gonna, I think I want to multiply that together. Yeah, I do. I'm just gonna distribute this first in, because I don't wanna do too many steps at once. So n squared plus n times 2n plus 1. Minus, let's just do the first easy, or maybe you can do all of it. What would this simplify to?
3 times n parentheses n. Or do you want to distribute that?
That's what I'm saying, we could just do the 3n first, or if you want to distribute the 3n and do that all the way, that's why I was kind of just asking you how you guys would see it. We want to go too many steps, or we just want to make it 3n times n plus 1? I'm going to make it 3n times n plus 1.
Okay. You're the professional.
Okay. Now what?
Plug in n?
Let's
No.
let's keep simplifying.
Still? Okay.
So what do we got to do here?
Factor?
Distribute, or FOIL, you guys
Or, I
sometimes
mean,
will call it,
foil.
right?
I don't know why I said factor.
Okay, so that's going to be
Square.
2n cubed plus n squared plus 2n squared, so that's how much? 3n squared. And then plus n. That would be my foiling, distributing there. Okay? So this is what I got for that first product. Minus, what do I get for that last product?
3n squared.
3n squared plus 3n, right? Okay?
Great. Now we plug in?
Oh, come on. We got like terms,
This is a 4-line problem.
right? Alright, combine our like terms, what do we get?
2n to the third
2n cubed,
plus.
n squareds are gone,
Yeah. Right, get them out of there. And then 2n?
it's minus 2n. Look at how easy this is going to get.
Oh, so easy.
Now distribute your 1 over n cubed.
Oh. So I get rid of your cubes over
So 2 minus 2 over n squared.
Word. I can't say no.
Now,
You plug in.
all you got to do, if I said find the sum of the first 10 of these, my answer would be 2 minus 2 over 10 squared. If I said find the sum of the first 100, 2 minus 2 over 100 squared. The first 1,000, and so on.
Has it been 2 weeks yet?
No, it hasn't.
Alright? So we could get our answers pretty simply by plugging in those different values of it. At this point now, it's real simple. Okay? Now, this isn't anything beyond what you guys are capable of doing. This is algebra.
a little high for me.
Okay? You know, the only real key to this is really kind of knowing your shortcuts for the sum of the perfect squares and the sum of the first n integers. Alright?
Goodbye.